Early 20th century South Africa was a massive, unmapped expanse of rock and dust. For early mechanized travel, this harsh landscape presented a near-impossible physical barrier. John Weston, a civil engineer, was determined to navigate this terrain. He built his first aircraft prototype in 1907, but the attempt ended in failure when the machine simply refused to fly. Weston saw that while bravery might start a journey, it couldn't overcome gravity. Moving across this environment required more than enthusiasm. It required a command of physics and material science to solve for mechanical limitations. To master transportation here, Weston had to solve for two completely opposite physical domains. This required contradictory engineering philosophies: extreme lightness to navigate the sky, and punishing durability to cross the ground. Success in one domain offered no guarantee in the other, as each environment demanded its own set of specific, deliberate trade-offs. In 1911, Weston's Weston-Farman biplane stayed aloft for over 8 minutes above Kimberley. Powering this flight was a 50-horsepower Gnome engine. Early flight was restricted by a basic calculation: weight. Standard engines of the era relied on heavy liquid cooling systems and massive metal flywheels, making them too heavy for most aircraft to lift effectively. This diagram illustrates how the Gnome engine bypassed that limitation. On the left, a standard engine uses pistons moving inside a fixed block. But on the right, the Gnome inverts this. The central crankshaft is bolted to the plane's frame, while the entire engine block rotates around it. Because the cylinders were bolted to the propeller, the entire engine acted as a giant spinning flywheel. This rotational momentum smoothed out power pulses without the need for a heavy, separate component. To handle this, the cylinders were machined from solid billets of nickel steel. This allowed for extremely thin, lightweight walls that could withstand high internal pressures, while the spinning motion itself dissipated heat through the exterior fins. But that spinning mass introduced specific operational difficulties. The engine acted as a massive gyroscope. Turning the plane in one direction was simple, but fighting that momentum to turn in the opposite direction was difficult and potentially dangerous. There was also the issue of lubrication. Centrifugal force threw castor oil directly out of the spinning engine. During flight, pilots were often coated in a fine mist of hot oil and fuel, an experience that carried a well-known laxative effect. The Gnome engine sacrificed operational comfort and steering symmetry to achieve a power-to-weight ratio that no other engine of the era could match. By the 1930s, Weston moved from the sky back to the earth. He turned his attention to transcontinental overlanding, an environment that required him to reverse his previous engineering logic. He designed a custom motorhome called the Prairie Schooner, built specifically for long-distance travel across the unpaved African interior. This 3D wireframe shows the shift to modularity. Weston traded lightweight aviation materials for a 1-ton Commerce truck chassis and a reliable Continental N engine. This established a heavy, durable foundation for the custom-built living quarters above. Off-grid endurance was the priority. The vehicle's fuel consumption was high, roughly 5 miles per gallon, so Weston integrated a massive 100-gallon fuel supply to manage the vast distances between fuel stops. Water management was equally practical. A 16-gallon tank was mounted under the chassis, connected to a hand pump and an inline filter. Even with the filter, the design assumed a requirement for boiling to ensure the water was potable. For river crossings, he designed a removable living area with a canvas cover. The canvas was specially waterproofed, allowing the vehicle to adapt to water obstacles that would have stopped a standard truck. Where the airplane required precision to stay light, the motorhome required rugged, modular self-sufficiency to survive the ground. The proof of this ground engineering was the 1931 expedition itself. Weston and his party traversed the unmapped African continent, moving through the same tall, wild brush that had once made mechanized travel impossible. They crossed the continent and eventually reached the urban streets of Belgrade, Bulgaria, completing a journey that spanned 2 worlds. Today, the Prairie Schooner is preserved in the Winterton Museum, while one of Weston's original Gnome engines has been named a national monument. Weston's transition between these two extremes provides a clear look at how material selection and system integration must shift when the environment changes. Weston's work demonstrates that progress isn't found in a single universal design. It's found in the specific, calculated trade-offs made to survive the environment at hand.